Hello and welcome everyone. My name is Rich Martin, Senior Technical Marketing Engineer at Itential, and I want to welcome you to our webinar where we will be discussing how to automate tribal network knowledge with command templates. So by way of the points we'll be hitting today, and kind of an overview of the platform and what we'll be doing, we will be discussing what a command template is. And I'm super excited about this because coming from a network practitioner's point of view, command templates are really, really exciting in that you can get started very, very quickly building useful automations using kind of that tribal knowledge that you already have. We'll unpack that a bit, but we'll also be showing you how to use these command templates, starting off really kind of a single step to multi-step command templates and why you would do that. That's also a part of expressing that tribal knowledge into a command template. But you always want to start with the basics and understand, how command templates work and some of the rules and things like that. We will also be looking at how to evaluate criteria for command templates. So command template executes a command, but also gives us the output, and we can evaluate the state based off of the output of the things we're looking at. We will be using then command templates for automating common tasks. And this is really where you can start to unpack and unlock the ability to really build some straightforward but exciting and very useful tools as you get started on your automation journey using just command templates and a few automation tasks. And then finally, what you'll end up seeing is that command templates are really great to leverage for what we call pre-check and post-check conditions for maybe more complex automations. Command templates in themselves allow us to see the state, do show commands and see the state of different network devices. But that's also useful when you combine that with making network changes to understand, is it safe to make a network change? After the network change is made, what does the state of the network look like? And compare those things together. So we'll take a look at using the output of command templates to do that. So with that, we will have three demos. We start, as always, from simple, and then we kind of build onto that and get a little more complex with each step, so you can kind of feel what this would look like as you're starting your journey building automations, starting with command templates. So we'll build a command template from scratch. We'll spend some time there, and then we'll automate it. We'll review the results. Then in the second automation, we'll do something that's probably very useful is we'll look for a MAC address on a number of network devices, and we'll use command templates for that. We'll introduce the ability to input data from a form and do some looping with a for each loop, as we also pull the list of network devices from another area of our platform from inventory. Then we'll be able to review those results. And then finally, we'll take a look at how to use command templates for pre-check and post-check conditions. It kind of helps to pull all of these different flexibility, the flexibility that's in command templates all together. So you can start to see, okay, as we go further and start building really robust automations in our platform, how command templates begins to really take its stand and its part as part of the overall ability to do pre-checks, post-checks, and determine conditions of the network. All right, so let me now share the screen and we'll get started in the platform. All right, so let's get started with command templates, because I think part of what is really exciting about command templates and understanding them is really just jumping in and starting to use them. So I'm in Automation Studio. This is where you build workflows, forms, JSON forms, and command templates, along with transformations and many other of the elements that will make up automations. Right now, we'll start with creating a new command template. So I can go here, select command template. And I'm just going to call this demo 0. We'll create that. Okay, so coming from a network practitioner's point of view, what makes me super excited about command templates is that really it's three things. They're really easy to understand, and that's part of what I'll show you here is to understand them. Because as a network practitioner, we already have an order, a procedure, if you want to call it a MOP, whether that's actually literally written down for a particular procedure. Here's how you create a new interface for a server or for a new site or for a customer. Or even if that's not a defined mop in a document, it's still in our head, right? There are things we know that exist that we must do specifically on a network device, CLI driven network device, that we ought to do in order to determine, the state before we make a network change and even after we make a network change. And that's really what we're doing. We're trying to express that tribal knowledge that unfortunately just rarely gets documented anywhere, and being able to put that directly into a template. So we're taking that command line set of instructions, and the things, more importantly, the things we are looking for as the outputs of that, putting them into a template and where we can actually use them in a flexible way. So number one, easy to understand. Number two, simple to build and to extend. We will start very simple here, and then we will move on and start to create more commands, more rules, things like that. And then once you've created command templates and you understand them, putting them in your automation gives you a lot of flexibility, both in building tools and utilities that maybe you or your team can use, directly, and then they become a necessary part of pre-checks and post-check conditions. That will not only save you time, but ensure that network changes get made correctly, and you validate before and after. All right, so let's get started. So let's just take a look at some of the things we have going on here. So first of all, we have this area here where we enter literally a CLI command. And in this case, we can start very, very simply. I have a device that I want to take a look at the details of the interface, and it's a Cisco device. So if I type in the Cisco the device CLI command, we're going to use gigabit Ethernet. Oops, one here. So let's do this one. I simply just to pop in this command. This is exactly what you type in a CLI. If I was looking at, I want to take a look at this gigabit Ethernet interface. This already pre-exists. But if I test this command now, I'm missing some information here. I need to device to test it on. So from here, I can do a search for all the devices in our inventory. So if I do a search for core ATL, I've got 4 of these devices. I want to use 0 here. Now I can actually test this one command just as it is to see what the output is. So if I click that, it's going to run that CLI command, show interface gigabit Ethernet 1.400 on the device core ATL 0. It's going to execute that command, and then it's going to return back the output from that. So if we were on a command line for that device and I type that in, this is what we would get in response. Now, again, if think in terms of understanding a condition before you make a change, right? What would be the right condition? If I was about to make a change, what are some of the conditions I need to search for to understand that it's safe to make a change? And that's where we kind of get into starting from the command and building a rule. Because again, if you're a network practitioner, you're doing this from the command line, you would say, well, I need to look at the details. Is the interface up already? Or, if I want to validate that a service is up on this interface, is the interface up? Okay, that's great. But is the line protocol up as well? So maybe that's something I want to search for as a rule. So now I can say, okay, based off of the output of the execution of this command, I can create a rule that I need to be able to see this. And that's where we step from just executing command to now being able to evaluate the output of that command to ensure that it contains something that I'm expecting to see. So in this case, if I expect to see this interface up, then I really want to know that this interface is up and the line protocol is up when I see the output of this executed. So now I've created a rule, and you can see here, based off of the output that we just ran, we had a result, and it passed because there was no rule that actually contained. So it's just going to do a default pass. But now that we've created a contain rule, we are saying that output now must have this as a form, this exact string as an input of the output. And if so, it will pass. And if not, it will fail. So now we can start to create a config template that gives us the ability to determine pass-fail conditions. So now if I test this, we should see a pass because I literally just copied and pasted. And this is one of the nice things about building, understanding and building very, very quickly. So starting with a single step, I can test within the command template section here and do live commands, show commands on this device to understand the conditions that as I build rules, whether they're pass or fail. So We can see that passed. I also have the ability to create different severities. Well, why is this important? Because as we'll see in a minute, we can have multiple rules for a single command. So I have severities here where I can say, hey, if the state isn't up and the line protocol isn't up as a result of this execution of this command, that's definitely an error, right? But in some cases, maybe I want to generate a warning on certain things. Maybe that, it indicates a potential problem or something that's missing but not critical to the state of that network service or its ability to forward network traffic. So I can do warning or even less than that info, because every one of these severities, we'll see in a little bit later on in our demonstration, can be used programmatically in an automation to evaluate whether everything passed. If not everything passed in a particular command template, what part of it failed. And so that's critical to be able to build out that kind of granularity in your command templates. But of course, we start very, very simple. So with this command, we're given the output here. We're testing one section of the output, whether that device is up and its line protocol is up. But we can also use the same output and create another rule to determine whether something contains another piece of information. So perhaps we want to test to see if this exists, which is the IP address. So I can again create a second rule, which I did, and now add another string to search for. So in this case, I expect a gigabit Ethernet 1.400 on this particular device to not only be up, but also to contain this particular IP address, meaning it's assigned exactly that way. So let's just do this. Let me change the net mask on it. Now, if we test this command, we'll see a little different output, because the first rule will pass. That should be there, but the second rule, we saw the output is going to be a /24 as a net mask, but I'm asking it to validate that it's /25. So now we had an overall result as fail, which is important here. But we also see that it was rule 2, the second rule here, that failed, that gave us the red X, but the first rule passed. So now I can start building out more and more rules based off of this particular single command execution output. So every rule that I build here is tied to the output of this the execution of this command. So any of this data in here I can start building rules off of. And again, I have the ability to also modify if one rule, if the overall command passes, if one rule passes, or all the rules must pass. So this gives you a lot of flexibility. Again, starting off very, very simple, and then building on as this goes. And I think as a network practitioner, you can probably think of a dozen things that you want to test on. That's all available for you right here. So even if it's not available within this particular command, let's say we can create a second command now. So now, because the output of this is just tied to the show interface command, we could also create another command, and we could do something like show interface. No, we can do show ARP bit at 1.400. Okay, so now we can show the ARP table, and specifically for this particular interface. Now, I don't know off the top of my head, or don't recall what that's going to look like. So in order to create a rule, we want to be very specific with the output. So I can just test this command now as part of the build out and troubleshooting, and see what it reports back to me. So now that's executing just command number 2, and it's going to give us the output. And of course, since there's no rule here, it'll be a automatic pass because there was missing variables here. So in this case, it gives us this entire line that says, oh yeah, I've got that IP address is in the ARP table because we know about it, because the interface is created and it's up, both from interface and the line protocol's up, and here's its MAC address, and here's the interface it's attached to. So I could literally go and do something like this now. I could say, hey, that's fantastic. I should be able to build my second command and have it match that particular line, but probably not the best way to do it. There's a lot of things that could go wrong here. The MAC address could be different. The spacing could be off. And so because of certain things that are a little more complex or a little more dynamic as part of output, really what we want to understand here is that from an ARP, from the ARP table perspective, is that these two things exist. the IP address and the interface, because then that would match and that would tell us, at least from the ARP protocol level, then um, those things are working and running. So what we could do here is we could leverage a regular expression. And because of that, well, now we can reduce some of this space in between. Regular expression, we can do that. And I could technically escape all of the dots, but it'll pass. It'll still work regardless. But probably I could replace all the dots. But this will now actually kind of white space everything, all the white and other characters in between this IP address and the interface, because those are the two things we're really looking for. So any of those things could change and be any type of different information, but it will match those things. So if we test this again, it's going to run that. It's going to get the same output, but now it'll do a regular expression match based off of what we put into this field, and then give us our pass or fail criteria. And we got a pass here. So it did match, that string did match this with the irregular expression here. So now you have a little more flexibility on how you want to create additional commands. And this is all well and good. We'll add this back to 24 because I saw that will be a fail there. But that's all well and good. So now, as you can see, you can create a command, have multiple rules based off of the output of that single command, or you can have a second command and then create a set of rules for that. We can create, we can use contains or doesn't contain, contains one occurrence of. We have regular expression or the inverse of a regular expression available to you. So now you can start building all kinds of more criteria. Some of the things that I've seen customers do is, building command templates to understand the state of a software upgrade, right? If you're doing a router upgrade and you want to understand everything from what files are stored on the file system. So there's a set of commands there, and you're checking in your rules to contain it has certain strings that match the new version. Then you're doing a live run, like a show version, and you're parsing through that show version to understand that the live state of the router is on and running that current version. And then the whole set of things, maybe to even check for particular routes, particular interfaces are up, those kind of things. That's how you can start building this out, starting very simple, really just copying and pasting data in to create rules, and then refining the rules over time, and even leveraging some more advanced string search abilities with regular expression to start creating these rules as well. So with that, that's really good as a start. But how do we make now this template? Because we're calling them command templates. So you can see where the commands come in, the CLI commands, and creating rules. But the template comes in by allowing us to define variables for what I've created statically here. And so this now, we can start to use this for more than just a single interface. As this stands, if I were to run this in an automation, it's statically built to only run these commands off of this very particular interface, gigabit 1.400. But maybe there's also another router that I want to run this on with a different interface name, or maybe there's the same router, but I want to run these commands, this command template set, on a different interface, 1.200 or 1.300 on that same gigabit Ethernet interface. So we can do a command variable, a variable substitution here. So I can take that out and just call it interface name here by substituting this format here. And anytime now that the interface name is leveraged, whether it's inside the command or inside the rules, I can now create a variable for those in here. If we're going to do that, we also need to go ahead and variabilize this, the IP address, because that could change. So just for that, we could do address and create a variable for that. So just as long as it's in that format, the greater than an exclamation point, or less than exclamation point, and then ending the variable name with the exclamation point and greater than, that will define a variable to use. So I'll finish this one right here. And now that I'm not statically entering this, I can still test all of these commands, because once I hit the test commands, The command template feature understands that we've created some variables here, and it's going to ask me what those variables, for at least for this test, what they should be. So I could do this, and we could do 10.40.40.1 and create variables there, and it's automatically filling this out for command 1 and command 2 because it's the same variable. If I click submit, then it's going to run this test case just like it did before with the static entries, but now with the variables substituted in the command template. So when this passes, we should see, again, a pass condition for both of these commands and the associated rules. All right. So overall, everything passed. Let me scroll down here. Everything passed. So there is an overall command template result when they run. Everything passed. In this case, we can take a look at the breakout command 1 passed, which was our show interface gigabit Ethernet 1.400. Notice that it did the substitution, right? So there was the variable, but it substituted. And then command 2 passed as well. Here is the command that we entered, but it substituted with the right command and gave us back that information, which was checked against the regex. The regex passed, so therefore command 2 passed. And since both of them passed, everything passes. And that's, again, combinable and changeable based off of some of the other options here available in the command template. If this is a type of template where you want, if one of the commands and rule sets passes, then it can count as a pass for everything. And then you have granularity within the commands itself as multiple rules are defined. How do you want the response or the reaction to be? Should all pass? Should one pass? Is that good enough? So again, giving you the ability to do that. And again, being able to variabilize that. Now it truly is a template. So from that, where does these variables come from? Because we've just been testing this. Because when we get into the automation side of things, so let's go over to this demo. Now I've created a workflow with a single task. That task comes from here, and it's going to run our command template. So if I search over here, you can see I have this command template task. If I click on it, it actually drops it on the canvas, but I've already done that and filled it out. This is going to run the command template. I've got a different one, but it's very similar to the one we just created. We'll look at it in a moment. So when I click on this is a task that's part of our platform that will run a command template that we've created in that command template section of our platform. What we need to do is whenever you have a task on the canvas, if you double click it, it's going to have variables that need to be filled out in order for that task to run, because it needs some amount of data. So what is the data that's necessary here to run a command template? Well, the first thing is it needs the name of the template to run. So that's the name that you create in this. When we created one a moment ago, I called it demo 0, but this is demo 1. If you'll notice, it's basically exactly what we've already done. It's using the same types of commands and variables here. And so that's going to run this command based off of the name. So we've specified that. Now, remember, since we've variabilized everything, when we ran the command template in the command template builder, it asked us where those variables were. But when you're running it from an automation, you have to provide the source of the variables. And you have a couple of ways to do that. In this case, I'm defining them statically, meaning I'm defining them here right in the details. And I'm saying here, I'm going to just define statically the interface name, variable name, and I'm going to give it the value of that. And then I'm going to define another variable called IP address, and I'm going to define the value of that. That matches up directly with the variables that are defined in the template. So the names are equal. So now I'm passing this JSON object with these two variables into the command template when it needs those variables, so that it can fill those out with the right information and run correctly. And then of course, the last thing we need is the device. In this case, I'm passing to it the same device we've been testing on, Core ATL0. It needs to be represented as an array. And so that's what I've done here with these brackets. That defines it as an array, but because this can be run on a number of devices, but in this case, I'm just going to run it on one device. And so with that, once you've filled out those variables, that's all you really need now to start running that command template inside of an automation. So when you run it, it executes it just like it executes it when we were testing it in the command builder. But now we get additional details when the command template runs. So now here the command template is running. We can go to visualize mode. And within visualize mode, we can kind of see it. Of course, there's a single step here. So visualizing it, it's pretty straightforward. But when this command template, it's running just like we were running in test mode. It's executing those two commands one at a time across the device we specified in the variables. That's core ATL0. And then it's going to give us the feedback on not only the data that it returned, but the condition of the pass or fail. And that's what's critical here, because we're moving from building the command template to running them in an automation. So within Job Manager, when we see these complete like that, when a particular task completes, we can double click it and see the metrics of how long it took to run. But in this case, we're going to look at the variables. So remember when I double click that in the automation studio canvas and I filled out those values. So that's what gets passed to this particular task to run the command template, just like we'd specified. And the critical piece here is the outgoing. So that's data coming into the task. Now we're taking a look at the data. The task runs, and now here's the data that comes out of that task. And again, this task is running the command template. So we expect to find the results of the command template execution here, and that's exactly what we do. Remember that in a command template, you have an overall pass or fail condition. That variable called result here at the top level, so this is the data that gets returned from the command template execution, tells us of the overall pass-fail condition. In this case, it's true, which means it passed. Remember, we have multiple commands and multiple rules within the commands. So here are the command results. So if we wanted to parse in our automation any of this data, it is available for us in an object, a JSON object, which means that it's easy to parse and easy to query and easy to extract data, especially with features like data transformations to pull out the information we need. So in this case, this was the very first command that was run. Remember our show interface? We variabilized it. Those variables were passed in from the incoming. And so it did the substitution, inserted our variable for the interface, executed it, provided the rules here of what we're looking for, and then gave us a result of true, which means that it passed. So that particular command passed. The second command that we created, or the second rule for command one, was looking at the IP address, recall. And so again, we had the substitution of the variable, and the result of this comparison was true. And then finally, we had a second command, which was the show ARP. From that, we were looking at the IP address and the interface name separated by the white space and the other characters in between that we use the regular expression on. Here's the rule that was once the variables were replaced inside that from our variables that we passed to it. And when it was executed, the result was true. And then, of course, here is the actual output for all of that as well. So all of this data is now within an automation available to you. And this is where a lot of that flexibility comes from once you build the command template. And I want you to think in terms of this too. Perhaps, all of this tribal knowledge exists a lot of times in the minds of a lot of network engineers. They just know these things. Getting them to be able to extract it and put it into a format that's not only just understandable to them, but understandable to everyone else. This is what makes this so clever and so useful for especially somebody from a networking background that doesn't have a lot of background on programming or writing automations themselves. They can sit down even with another party who's building the network automations and say, okay, we need a command template to ensure that, the interface is working. The routes are up, the MAC table, the ARP table looks right. What does that look like? And the network engineer with the tribal knowledge can go, oh yeah, that's easy. I would log into the machine. I would run show interface this, and I would look for this particular information. Then I would do a show ARP and I would look for this particular information. And now you can transcribe that tribal knowledge into a command template. And all of that data now becomes available in the automation, where the automation engineer or the network engineer who's doing automation can now start to use all that information. And that takes us to our second demo. So let me close this out. So let's take a look at the second demo. Again, a little more complicated, but this is precisely what I'm talking about. The heart of this is running a command template. But before we get to the command template, we really need to have our data. We're not going to statically define a lot of data here. We're actually going to get a lot of data from other sources. So in this particular case, let me tell you the overall idea of this automation that uses this command template at its heart is I need to find a MAC address and I don't know which device. I know the MAC address, but I don't know which device it's on. And so I wish I could query a series of devices and determine if that MAC address exists. And if so, on which, I know the MAC address exists, but on which device is it on? So that's what this is doing. So a couple of things going on here. First, let's take a look at the command template. So again, this is that one task run command template. I'm defining the name of the template. So it's called CTW demo 2. We'll take a look at that in a moment. But you'll notice here, instead of statically defining those variables, the interface like we did before where I defined the gigabit interface and the IP address, this is a little bit different. So the variables are coming from another source. And so that source here is another task, another block on the automation in the automation workflow. And this particular task is called the CTW demo 2, which is actually a data transformation. We'll take a look at that in a moment. And of course, the devices that we need to search for that MAC address are also going to come from another source. Again, CTW2 demo 2, which is the data transformation. So if let's take our first stop at the actual command template itself. Again, this is very straightforward and simple. In my lab, I don't have access to physical switches, which would be nice because then I could do something that's pretty obvious, like show MAC address or show MAC address table or show MACs. But in this case, I do want to show a MAC address, but it's got to be unique and assigned to a particular interface. So I'm just going to use this command to show the interface for gigabit Ethernet 1.400, which exists on several of these devices that I have. Each of them have unique assigned addresses, and we'll search for them and find out which one it's on. But again, because command templates are flexible in your environment with real physical switches, you could input the command here that is appropriate for that type of device to just show the MAC address table and see what MAC addresses exist on which interfaces. And again, when that command template is executed, you create a rule searching for the MAC address, but then the output becomes available. And that's, again, something you can parse through within the automation to extract data from that. So this is very straightforward. I just want to find a MAC address. I want to see the output of this command, and I'm searching for a MAC address, in this case, which is a variable. So where does that variable come from? It comes from our form here. This is where I'm actually going to ask myself to input a MAC address. So the user that runs this will be asked, what MAC address are you looking for? This could come from another source, but in this case, it's just a very simple JSON form. So you create those within the platform. The next step here is, if I'm going to look for this MAC address across devices in my network, I need a list of devices to search across. So where does that come from? So another section of our platform we call Configuration Manager allows us to onboard different network devices. And you'll notice here's Core ATL0 along with some other ones. And all of the network devices we have in our lab are onboarded here. But once these are onboarded into the system, not only can we do automation on them, but one of the things we can do is you can create a device group. So now I can create a device group called Core Routers, which includes these 4 routers. And I could also include other routers into this if I wanted to. But now this is going to be the device group or the list of devices that I want to do this search for a MAC address. So that's going to be part of our inventory that's available in Config Manager after I've defined a group. So now I can iterate through that group and get each device name as necessary. And that's exactly what's happening here. This particular call, again, comes from the right-hand side. And it's called Get Device Group by Name. It's part of our Configuration Manager features here. These tasks are all available, and they all relate to that Configuration Manager portion of our application, of our platform. And right now, what I'm doing, if I double-click it, we can look at the variables it requires. In this case, it requires a single variable, which is the group name called Core Routers. And that correlates back to here. This is the group name that I defined, Core Routers. So when this particular task is executed, it's going to return a lot of data, but the data we're really interested in is the list of devices, that list of 4 routers that I included in that group. So this is a query to extract that information. So the output of this goes into the query, and in this query, I want to query the variable devices, which is going to give me a list of the devices as an array or a list. And I'm going to query the object that comes from this task, get device group by name. That comes from here. So the output of this data goes into query. We're going to extract data from there. And now we're going to go into a loop because we want to iterate over this, over each device one at a time. So I have a list of 4 devices. I'm going to start with the first device. I'm going to do a transformation. We'll take a look at that. The first step here is a transformation. So what does a transformation look like? This is how we can also format data and information. So from previous sources of information and data, so that it can be used in subsequent tasks in the workflow. So on the left-hand side, we have something that says incoming schema. This is the data that we want to use as a source, because we're going to have to manipulate it, transform it in some cases to match a format that becomes usable for another task, another call in the workflow. So in this case, the MAC address is going to come from our form. We'll see that in a moment. But the device name, that comes from another source. That comes from that task that's querying configuration manager for the list of devices in that device group of core routers. So that's where that data comes from. So once that data is passed into the data transformation, we can map that MAC address just as its input directly into an output variable. This becomes used in the configuration template variables. We'll take a look at that in a minute. But then that same data, that MAC address, is going to be used in this something called template literal, as well as that device name. You'll see why in a moment. But now the device name, which was passed by the call to get the list of devices in the group, is going to be part of an array, because that's what the requirement is in order to execute the command template. It has to be in the format of array. So we're transforming a device name as a string into an array that's a single device name. And then finally, the template literal. This is used, oops. If we look at this, this is used to format more of a friendly message, or a nicely formatted message. So in this case, I'm using this template literal to substitute variables for the MAC address and the device name, and formatting a nicely formatted message, so that when a device is found, we can actually see that in a little pop-up and view that information that gets passed to it. So again, using these variables as part of a template literal, so that outputs as a string. And this is going to be used for another task called the view diff. So let's go back to our automation. We've covered this task. We've covered getting the MAC address from a form. We've covered getting the list of devices, extracting the devices, iterating through the loop, transforming the data. Now that data that I just showed you in that transformation now becomes useful here again. The data transformation is the task. It outputs those outgoing variables, and that variable is being used here. The outgoing variables from that same task is being used for the device name. That's where we're transforming it from a string into a single element array. So that's where that data comes from. Now, when this command is run, it's going to run our demo template again with that data. And now the output of that gets evaluated. So remember all that data that gets output from a command template. We're really interested in the overall pass-fail condition here. Even though we could query or create a series of evaluations to query for any element of the rules passing or failing. So if I have command 1, I can query over rule 1 or rule 2 to see the status. Or for command 2, I can query over rule 1 or how many ever rules to understand the status. For this, I'm simply querying on the overall result of the pass-fail status, just so that I can understand where we should go from there. So in this case, I'm searching for a MAC address. Here's the first device. We execute the command template. It's going to give us back a pass-fail status. Pass meaning I found it, so the result will be true. Fail meaning I didn't find it in the output of that show command. And so in this case, the evaluation says if it's true, if it passes, it's going to go to this task, which is going to allow us to view the data that's passed to it. And in this case, it's not found, so it's actually not going to do anything. A stub is just kind of sitting there, but I wanted to show you a failure path so you would understand that this is where it's going if it doesn't find that MAC address. So in this case, if it finds it, we should have a little pop-up window that allows us to view the data of the information. All right, so that's the overview. And so with that, we could run. And so the very first thing is that first task to ask us what the MAC address is we want to search for. So again, this is built within the platform. And I have a MAC address here. So this is going to um, be associated with the device Core ATL1, just so we can confirm that. And so we're going to run now. And now we'll go to visualize mode so we can kind of see what's going on here and track this. So remember, it asked us for the MAC address. I entered it in. Now it asks for the list of devices by that group name, core router. So now it has a list of 4 devices. So the incoming data was, hey, config manager, give me the list of the group name core routers. And it said, here we go. Here's some other information that really is not necessary for us right now, but the key thing here is this list of devices. These are the 4 devices that were part of that group. In order for the for each loop to iterate over that, it just needs that list of core devices. So we extract that with a query. So the incoming information is the config manager output, but I'm asking it just return the data that we need so that I can pass it to the for each loop. In this case, just give me that array of those devices. So that gets passed to the for each loop, and then it iterates one at a time. So the first time through the loop, it's going to use the first device listed that was provided. So in this case, Core ATL0. So that's the data transformation. We after the data transformation is done, it's going to actually run the command template for, in this first iteration, notice iteration 1, Core ATL0 was that first device. What was the result? The overall result was a fail. But in the second iteration, that's where we're at currently. Go here, the incoming variable, because we're iterating over that list through that for loop, was Core ATL1. Aha, so that's the MAC address that should match. And now the results were true. So that the first time it iterated, it would have gone down this path because it didn't find that MAC address. That MAC address is associated with Core ATL1 and not 0. But the second time through, it would have taken the eval path this way, which is now where this is sitting. So a blue task is a task that requires a human intervention. It's a manual task. So if I click here, I can grab that task, work it, and this is the output that it's telling me. It's saying, hey, that MAC address that you asked for us to search, we ran the command template on Core ATL1, and the command template came back saying, yep, I matched based off of the rule. And so here's what you need to know. That is available on Core, that is associated with Core ATL1 based, and it's on interface gigabit Ethernet 1.400. So now that that's done, if we go back to visualize, it will go down the third iteration. So now we're at iteration 3 running that command template. Now, one of the things we could have done too is if this is the type of automation where that MAC address is unique and we should only see it one time, we could go straight to an end and not run any loop, any other iterations beyond that. But for the sake of this, we will continue on, and it's going to iterate through all 4 of those. In fact, if you look here in the parentheses, then you'll see that it's on iteration 4 of command template. And finally, the job is complete. So what it saw was the MAC not found task was run 3 times, but the MAC found task was run 1 time, and that was the time it was found on Core ATL1. All right, so that's how you can use the command templates for basically a tool that can really help you save a lot of time as you're building automations. But really, another flexible place, and really where command templates shine, is when you're making network changes. So I wanted to highlight the ability to evaluate the output of a network or a command template run, and so how you can parse through that in a simple way and even get more complex. But ultimately, you're going to want to use these as elements of a pre-check condition and a post-check condition. So in some cases, because you want to run a command to execute, if I'm going to create a new interface and my assumption, for instance, is the interface doesn't exist, then my command template should, for a pre-check, if I show an interface for an interface that doesn't exist, it will give me an output of one kind. But then if the interface does exist, it'll give me an output of a different kind. And I can use that as both a pre-check or a post-check condition before I configure a network interface. So that's where these things can also come in clutch and their flexibility, being able to give you one of multiple pre-checks and post-check steps. I am not evaluating the output of these when they run. I kind of showed that in its element in the last demo. What I really want to show you here is just how you can use the output of this in a diff so that you can see changes before and after something is made. And so in this case, I'm just going to make a change to an existing interface. So the first thing here is we're going to show a form that's going to ask me for details of an interface: IP address, net mask, port description. We have a transformation task here. It's very straightforward. It's going to get that data from the form is going to get passed into the transformation task. And all I'm doing here is I'm splitting it out into individual variables for IP address, net mask, and description, because that's going to be used for my make network change. So this is actually going to change the network, the device. So I'm going to, whatever we input in the form is going to get passed into here. Notice that this variable is going to be coming from our CTW demo 3 task, which is the transformation that we've defined. And these are the 3 variables that we've defined within that transformation: IP address, net mask, and description. And they match here: IP address, net mask, and description. So that's where those variables come from. And again, that source of that information comes from the form that we'll fill out. Statically assigning this to core ATL 0, it's our guinea pig, as well as the loopback interface. But those could also be variables coming from the form or somewhere else as well. But just to show this, this is a demo. Now, what about these tasks? These tasks are exactly the same. This is a command template that we're going to run called CTW demo 3. I'm not going to assign any variables here. So this is an empty object. And I'm going to run this device statically on core ATL 0. We've showed iterating through different devices in the last demo. And in this case, I just want to show interface loopback 301 because this is the interface I'm going to change. No rules here, so we aren't going to do any evaluations, but in a more complex built-out pre-check, you would most certainly want to do evaluations here. But this is showing you how the use of being able to use these as a pre-check and post-check condition, looking at output. So pre-check, what does the state of the device look like before the change? Then we make the change. Then we run the same command to look at the state of the interface, the network, and in this case, the network interface after the change. And then let's take a look at the results and see how that can be a helpful tool for network engineers building and using command templates. So we can say, start this job. It'll take us to job manager. So now the job is executing. Of course, the first task is to ask us for some information. In this case, I'm just going to put some new details in here. Now we'll run that. So it's going to take that data that I inputted into the form. I'll go to visualize here. It's going to go into our transformation. That transformation is going to extract that object and its variables into independent variables because they were used for both the command template pre-check and the make network change, primarily for the make network change. So we captured the state of that interface before a change was made by running this template. Now we're actually going to make the change. So now that the state of that interface is going to change. Its IP address is going to change. The description is going to change. The net mask may change. I don't recall what it was before, but that's the point of this. We're going to see it in a moment. Now we're taking the state, a capture of the state after the change, right? And now this particular task is part of our platform to allow us to see the differences between two of these template captures, the output of these two captures. So that's where it's at now. You'll notice it's a blue box. So again, it's a manual task. So if I go here and we can take a look at it, you'll notice that it gives us the output. So now that those two, the pre-check and the post-check, were done, and they were done at different points in time, one before a network change was made, one after the network change is made. So before the network change is in red. So now I can visually quickly see that before we made the change, the description was different. It was called not used, and the IP address was 1041.20.1/24. But now after the change, I have a new description, hello world, which is what we entered into the form, as well as the IP address and netmask as well. And if there's a lot, so if your command template has a lot of data going through, there's also a way to minimally look at this just to see the changes that were made and not the full data that was available, especially if this was actually an interface that was actually passing data. So the inputs and the outputs might be incrementing. So we can just take a look at certain information here. So in this case, we can very quickly visualize what used to be, what is now, at before and after the change. And again, if I click proceed, it will continue and finish the automation. So again, this is the flexible way of being able to use command templates. Network engineers can really easily understand how command templates work by expressing that existing knowledge that they have and building out command templates, command at a time, looking at the rules, the output, and building rules based off of that. Building multiple commands, multiple rules based off of whatever it is that they're the situation they're trying to test off of. And again, this is a lot of tribal knowledge now can be used. And these command templates can be reused in different automations. So once you've built one, it can be reused in different automations if the criteria that you're testing and looking for is relevant to that particular template. But once that's done, you can build them, extend them out, and then use them in different flexible ways in automations. Everything from utilities that can help you save time by looking at devices for MAC addresses or routes to building robust pre-checks and post-checks. And with that, I want to say thank you very much. We're running up against time, but hopefully that helped fill out some knowledge of how network engineers and practitioners can get started in automation really from day one, building command templates and then learning to build the automations around them, or even working with another team, another group that could be responsible for building automations. And now you have participation in building these automation workflows. And most importantly, transcribing that tribal knowledge that exists in so many areas into usable and reusable components that can be part of overall automations that really make a difference for your company. With that, I want to thank you very much. Until next time.